buffers. What do you think of when you hear the word buffer? Like a bumper or a cushion. If you watch Thomas the Tank Engine, the buffers were the things at the end of the track that kept the trains from going off. But it's like a cushion between two things, right? A chemical buffer is something that sort of cushions the solution against pH change. Buffers have significant amounts of both a weak acid and its conjugate base. So what happens is if you add base to the solution, the conjugate acid the weak acid neutralizes it. If you add acid, the conjugate base neutralizes it. So it's got both an acid and a base in it. And your blood has a buffer in it. And your blood is the pH of your blood is very tightly regulated by your body. And part of what goes into that is carbon dioxide. In healthy individuals, your blood pH is between 7.36 and 7.40. Very, very tightly. If it gets down below 7.0 or above 7.8, you die. So your body regulates the pH very, very closely, and it uses buffers to do that. Here's an example of a buffer system: acetic acid and sodium acetate. So here, when you add base like sodium hydroxide to this solution, the acetic acid will react with it and neutralize it. If you add acid to the solution, we have a conjugate base here, the acetate ion, and that will neutralize the acid. So it can take care of whatever's thrown at it. It doesn't have an infinite capacity. Eventually you overwhelm the buffer. But for small amounts of acid and base, it can absorb that and neutralize it without the pH changing very much. Here's a picture of that happening. If acid is added, it can hook up with the conjugate base. If base is added, the acid will neutralize it. So which of the following is a buffer solution? And this is kind of what you need to know about buffers, be able to identify them. You have to have a weak acid and the conjugate base, meaning the anion of that weak acid. So here we have H2SO4 and H2SO3. Is this a buffer solution? No, both of these are acids. This is sulfuric acid and this is sulfurous acid. That's not a buffer system. Not. How about HF and NaF? First of all, is HF a weak acid? Yes, it is. The conjugate, what's the conjugate base of that weak acid? We take the HF, and if we take off an H plus, what's left? F minus. Is this the salt of that? Yes, it is. This is a buffer system. Now, this one, HCl and sodium chloride, that looks like it would be a buffer solution because here we have HCl, that's an acid, and here's the chloride, that's the conjugate base. The problem is this is a strong acid. The strong acid ionizes completely, and so you don't have any acid left to be neutralizing the base, so that one's not. How about letter D? Is that a buffer solution? A weak acid and its conjugate base. Nope. There's no acid. Here we have sodium chloride and sodium hydroxide. There's no acid. End of chapter 14. Right on time. So those are the things you should know about chapter 14.